Young people, welcome back. BNB in the house, y'all. Really excited because there's only 3 questions. Yeah, I said that. I'll say it again. There's only 3 questions, but we've got a cool one. It's one that actually BNB will always show a video for this lesson. There's so many different ways to approach these. One of my favorites is making sure you have a graphic organizer or just a table to fill in. But all that talk, and you still don't have any idea what we're doing here, right? We're doing chapter 2, lesson 9, what they talking about, right? So weighted averages, guys. For chapter 2, lesson 9, weighted averages, the goal is for students to solve mixture problems. And mixture problems, you say that, and you'll see in a second. And of course, the second objective is solve uniform motion problems. So both of those 2 things, the way they're wording them, I try my best to make sure that students will be able to solve mixture problems and motion problems. The concept would be basically expressions and solving expressions. The skill would be solving. Also writing. Basically, we're doing some word problems. So with all of that said, some of the things that you're going to see might be a little confusing. There might be a couple more pauses than usual, but at the end of the day, guys, this is where, if you don't know what POC stands for, today's the day. Point of confusion. So when your point of confusion comes in these mixture problems, you definitely want to say, okay, I'm confused when you put b minus 4. I'm confused why you wrote that equation, or whatever it is that may come up. But again, guys, what I love about these is I've seen kids not write anything down, do these in their head, and just come up with a logical answer. So with that said, guys, let's get it started. If you didn't believe me, you're going to believe me now. Take a look, and here we go. You already see it, you already got it, guys, but guess what? There it is. One handout. One handout, 3 questions. And honestly, guys, the video could take 20 minutes, 10 minutes, all depending on how we're gonna go. But be prepared because there could be a pause. Seasoning, weighted averages. Health food stores sell seasoning, blends, in bulk. So kind of like Costco. When count. One blend contains 20% basil. Sheila wants to add pure basil, right there. Pure basil is 100% basil. You see it in the chart. To some 20% blend to make a 16 ounces of her own 30% blend. So I already see the highlight, right? 16 ounces of her own 30% blend. Let B represent the amount of basil Sheila should add to the 20% blend. So right now, let's get a quick pause. Now, the reason why I got this quick pause in, guys, is POC. Right now, who's already confused, right? Where's your confusion at? I only highlighted one thing, but this is where I would ask my teacher, or you go back and say, hey, did you do number 1? Bearded math brother didn't help. And ask your teacher what is the important information and how it helps them to drive filling in that table, right? Making sure you get everything in that table correctly. So the reason why I'm pausing is you already noticed that I pointed out it says 100% basil in the chart, but it says pure basil in the paragraph, in the words, right? The sentence. So right there, 100% basil, well, that's the pure basil that she's adding to the 20% blend. So think about it this way. There's 3 boxes, right? The top box, 20% basil blend. The next box, 100% basil. Then the third box, 30% basil. Think about this. All she's doing is adding the first 2 to get the third. But how much does she need to add, right? So literally that table kind of works if in your brain you're going, the first plus the second gives her that 30% blend. But what did I highlight? I highlighted what the question was, what the information is that is going to drive us to getting that answer. And that's where it says 16 ounces of her own. So ounces and amount of basil. That's what we're filling in. All right. So right now it says 16 ounces. Would I put that for 20% basil blend? No. Would I put that for 100% basil? No. Would I put that for the 30% basil blend? Yes. Because it says 16 ounces of her own 30% blend. So let's get this thing moving again and be prepared for another pause. So, as I was saying, guys, what information could I pull from there that I know for a fact is going to help me fill this mess in? Well, there it is, 16. Now, how much to represent B? B is my variable. Let B represent the amount of basil Sheila should add to the 20% blend. So if you think about it right now, guys, I just kind of filled that in. 16 minus B, and then of course B, and then of course 16. So the amount of basil, because all three are basil, but think about it. 30% times the 16 ounces. Now, 1 ounce, we don't even know because it's just B. B could be 3, so 3 times 1 would be 3 ounces. I'm gonna pause because the table's filled in. So there's a lot of pauses, right? Boom, pause. So as we're looking at this, guys, what do we see? All right, we see 16 minus B is a 20% basil blend. Where did we get that from? Oh, that's right. Well, whatever it is, it's gotta be 16 minus B because B is the amount she's gonna add and 16 is the total. So if I know I got a total of 16 ounces and I take away B, it's gonna leave me with whatever's left. And whatever's left is what she started with the 20% basil blend. POC, let me say it again. One more time, guys, remember, the first two add up to the bottom. So 16 minus B, and then if I was to add B to that, it would give me 16. Because the negative B and the positive B would cancel. So yes, guys, it makes sense to me, but it's gotta make sense to you. So the first column we filled in. Now for the second column, we're just multiplying. Because when it asks you the amount of basil, well, okay, how much basil is in there? 20% basil. How much basil is in there? 100% basil. How much basil is in there? 30% basil. So 30% times 16 ounces. There you go, change the percent to a decimal. 100% times, we don't know. Let B represent the amount of ounces for the 100% basil. So B times 1. Yeah. And of course, 20% times the quantity 16 minus B. So again, that second column, I literally got by just understanding what's happening. I want to get a total of 16 ounces. I'm using 2 ingredients. So, all right, am I using 8 ounces and 8 ounces? Or am I using 10 ounces and 6 ounces? Am I using 12 ounces and 4 ounces? That's what we're figuring out. Let B represent the amount of ounces for pure basil. But how many are we using of the 20% basil? We don't know, but we do know the total. So the total is driving us to figure out the information that we don't know. And that's what we're about to do, guys. We're gonna write an equation to help us solve for what we do not know. Let's get this moving. Bam. All right, guys, so with the table filled in, I think one of the things we should do is go ahead and get a little beer, get a little room to work. So, boom, and the questions were there because part 1 was to fill in the table. Once our table is filled in, then we can answer B, C, and D. Because remember, there's only 3 questions on this handout, but question 1 has A, B, and C. So it's 3 questions in question 1. Oh, I'm still playing with this. There we go. That looks good. Complete the table representing the problem. Write an equation to represent the problem. So the equation has to have an equal sign. And remember what I was saying earlier about make sure you get what's going on. And what's going on is she has 1 ingredient and she's going to add a second ingredient. See, I said add, there's addition. And when she adds the first ingredient, which is the 20% basil blend, to the second ingredient, 100% basil, she's going to get her total blend of a 30% basil blend. So all I did, once again, guys, I took the first, and I took the second, added those two to get the third. That's it. Now, can I solve that though, right? Of course I can. How many ounces of basil should Sheila use to make the 30% blend? Well, how many ounces of basil? Well, now I'm solving for B, guys. And here's where you're solving. I don't like the way that looks, guys. There's an equal sign inside the parentheses. You see it, I see it. Hopefully I'll catch it later. But solving this using the distributive property. 20 hundredths times 16, 3 and 2/10, minus 20 hundredths B. Just distribute it to 20 hundredths. And then of course, do I see it now? It's basically 1B, or keep the decimals, right? And then of course, now I see it. And now I'm gonna fix it. Parentheses close, equals. And same thing here, guys. I just need to recognize that 30 hundredths times 16, multiply, and I'm good. So, did my first step, distributive property. Next step, of course, is to collect like terms. So on my left-hand side, you'll see the second and the third term, 0 and 20 hundredths B, plus 1B. I can collect those two terms, 3 2/10 minus 0 and 8. And if I say 8/10 or 80 hundredths, hey, argue with your teacher. Don't argue with B and B. So 8/10 B is equal to 4 and 8/10. Subtract the 3 and 2/10 from both sides. And now we're looking at a two-step. And again, guys, the decimal hopefully doesn't give you too many problems here. Calculator, I mean, even photo math can take care of a two-step for you, right? But showing your ability to solve. And here it is again, guys. Decimals, dividing decimals, multiplying decimals. Nice skill you need in the back pocket, right? Hey, look at me showing a little work. So, you know, it makes the teacher happy when you show that work, right? So, solving the equation, and here, let's go ahead and show. Am I going to show it? Maybe not. B is equal to? B is equal to? 2. B is equal to 2. So what does that mean? Right back up to that chart, where's the B at? It's underneath ounces for 100% basil. So I need 2 ounces of 100% basil. How many ounces of the 20% blend should she use? Oh, you mean the first in the column up there. 16 minus B. Okay, well, 16 minus B, well, B was 2. 16 minus 2 is 14. And there it is, guys. As I said before, 14 plus 2 is 16. So when I simplify it in my mind, hopefully when this table comes up, it gives some, it helps it make sense, right? It makes sense to me. That's why I was able to set up that equation. All right, guys, so that was number 1. Did you have fun? So number 2, guys, a little different, but the same. Yeah, men and women, a little different. We're the same now. All right, guys, so reading all of that will be fun. Let's go for it. At 7 a.m., 2 groups of hikers begin 21 miles apart. 21 miles what? And start hiking towards each other. The first group hikes at an average rate of 1.5 miles per hour. Carries the tents, the sleeping bags, and cooking equipment. The second group, so they see the first group and they're walking in one direction. And second group, where did I leave off at? The second group hiking at an average rate of 2 miles per hour, carries food and water. Let T represent the hiking time. So guys, I filled in 1.5. Why? Because it's at a rate of 1.5 for group 1. That's what I'm gonna put in there, right? So that's their rate. And then it's at a rate of 2 miles for group 2. So just filling in the table with the information that I see. And you think about it, guys, what other numbers do we have in there? 21 miles, 21, right? But I'm gonna use the 1.5 and I'm gonna use the 2 exactly where it needs to be put at the rate. So now I'm showing my visual again to point out what's happening. Well, you got one group starting on the east, one group starting on the west, and they're gonna meet in the middle. So one group is walking at 1.5 miles per hour. Not miles per hour, at a rate of 1.5 miles per hour. Now we don't know how long, that's why there's a T there. Did they walk for 1 hour, 2 hours? Who knows, right? The other group, they walked for however long, 1 hour, 2 hours, you know. But at a certain point, they're gonna meet in the middle, right? And that's why I put the equal sign, because this is the problem. It's you understanding that you wanna find out the amount of time it's gonna take. T is the variable. Since they're 21 miles apart, group one's gonna walk a distance, I go this way. Group one's gonna walk a distance, group two's gonna walk a distance, and they meet in the middle. So add this plus this, and you got it. So there's your equation. Bing. And of course, that's B. You haven't seen the question for B yet, but that's B. It'll come up here in a minute. 1.5 T plus 2.5 T is equal to 21. So distance is equal to rate times time. So distance, we know the total distance is 21, but we don't know the distance for the first group, and we don't know the distance for the second group. We just know that together, added, it was 21. So that's what we use. We set up an equation to find the value of T. 1.5 T plus 2T gives me 3.5 T. 3.5 T is equal to 21. Divide both sides by 21. And T is, use your calculator. You already know, right? You already know. So finding out what T is, guys, how can I put this? Is solving for the variable. The question says, write an equation using T that describes the distance traveled. Done. How long will it be until the two groups of hikers meet? Oh, okay. It will take 6 hours. Oh, why 6 hours? Because T equals 6. It's good to me. That went kind of fast. Should have paused, but you're okay. So, go back, check that one out, and again, this is the one. So, get a pause in. And this will be our last pause, because I remember this one. Went through the distance, rate, and time question pretty fast. And the reason is, if you haven't seen DRT, distance equals rate times time. Now, I got some videos on it, it's all over the internet, but that question, again, wasn't a mixture problem. However, like I said in the beginning, they're similar, but they're different, right? So you'll always hear about 2 trains leaving the station, one going east, one going west. How long until they're 30 miles apart? Well, this one was 2 trains, leaving from different stations, going, meeting, how long until they, meet. Same thing with airplanes, so you're gonna have these questions with distance, rate, and time, where you are setting up an equation where you're adding, because you have the total, but you don't know how much the first train or the second train did, or in this case, how far the first group walked or how far the second group walked, but you can't figure out the variable of time, all right? So with that said, guys, we are always going to have different ways to get an answer, but it's all in the approach. So in these 2 approaches, I showed the arrows of them coming together, and then in the first one, of course, we had a table. And sometimes I like to draw the beakers and show the 30%, show the 20%, show pouring them together to get, the 30%, the 20%. I can't remember what the percentage was, but you get it. So for this one, guys, I want you to understand. Let's get it. And we're going. So guys, straight off the rip. Surgeon sells a mixture of Virginia peanuts, Virginia peanuts and Spanish peanuts for $3.40. To make the mixture, he uses Virginia peanuts. It costs $3.50 per pound, and Spanish peanuts cost $3 per pound. He makes this 10 pounds at a time. So this is where I am challenging, and I would do this in class, guys. I'm going to do it to you. How would you like to approach this one? They're not giving us a table, not at all. I can tell you, draw a picture, absolutely. But I want you to take a second as I'm writing this last bit here. What do we know? Well, what we know, and this is what's crazy, the mixture is $3.40 a pound. I buy 10 pounds, Guess how much that is, all right? Now, the mixture though is literally made up of 2 different bags of peanuts. So again, I got 2 ingredients. I want to mix one and mix the other to make my blend. I just want to know how much of this one and how much of that one. And that's what I mean by there's so many different ways to do this. I mean, think about it. If I actually gave you, they'd be Legos, can't give you peanuts. My son's got a peanut allergy, I ain't bringing peanuts into class. But I represent one peanut with one color Legos and another peanut with a different color Lego, and I go mix. And every time you mix a pound, it costs how much, right? Then the second pound, how much, right? But we gotta get a total of, how much? $3.40. And that's for the mixture. So I'm gonna leave it at that, guys, because whether you're talking about 1 pound, 5 pounds, 10 pounds, the mixture is gonna always be consistent. So guys, this is one of our shorter videos. You know, if you were here from the beginning, guys, we got 45-minute videos. I think I might even hit the 50-minute mark. Over here, like, dozing off, right? Videos are so long. But then we went ahead and made sure that you guys can get what you need in a quality amount of time. So in this one, guys, you are definitely gonna want your teacher to go over mixture problems and to go over the, what do we call how you call them, the train problems, guys, plane problems, because literally they'll give you one where they're talking about the wind draft and you literally gotta subtract because the plane is getting slowed down by the wind. Or the other way, if you get on a plane and you get there early, well, guess what? The wind was pushing the plane. So it adds another component to the problem. Guys, I'm not gonna drag this on any longer. I hope you got a little bit of help from this video. I hope to see you the next time. BMB out.